When you do a single sample t-test, you're comparing one sample, a single sample, to some sort of population value. So, for example, I have this data here which shows a bunch of different students and how they did on a bunch of quizzes, the final, and then their final percent grade in the course. And if I had access to data for every other student who had taken this course in the past, then I could compare how this class did to the rest of the population who took this class. So to do that, you would go into Analyze, Compare Means, and then One Sample T-Test. In the dialog box, you would put your test variable. That's the one that you're interested in, so I'm going to use final percent grade. And in this box down here, the test value, that's where you would enter the population value that you're interested in comparing your mean to. So let's say that I knew that in the past, most people who took this, fake course from this fake data set got 80%. You don't have to change any of the default options or worry about the bootstrap option, but I'll show you what the options look like just in case. Here you can choose the level of your confidence interval. Typical in psychology is 95 or 99. And you can also tell SPSS how you want it to deal with missing values. In general, I would keep this as an analysis by analysis. What this means is that SPSS will use any data that it can for when the participants have that data. So if you have something for final percent grade, it'll use that value. When you select this one, it will delete any participant who is missing data anywhere. So for example, if somebody was missing a value here on final exam grade, then they would be excluded from this analysis, even though there's data there for SPSS to use. So in most cases, you'll want to stick with the default, which is, telling SPSS use what data that you can. To run this, you press OK. And this will pop up two different tables in the output window. In the first case, you will simply get your descriptive statistics for the variable that you selected. So here we can see that there were 105 participants. Our mean is 80.34, and our standard deviation is around 12. And then we have the standard error of the mean, or the standard deviation of the random sampling distribution of the mean. In our one sample test table, we get an indication of what the test value is. This is the population mean that we're comparing to. So we are comparing the mean of 80.34 to a population mean of everybody who took the class before who got 80. And then down here is our formal statistical test. So this mean difference is simply the difference between the two means. So it's about 0.343. And if you take this value here, which is the mean difference, and you divide it by the standard error, then it will give you this value, the t-value. Okay, so looking at our t-value, we get 0.290 and our degrees of freedom is 104. And our significance or our probability of getting a t-value of this or more extreme is equal to 0.773. Because this is greater than 0.05, we say that the test is not significant, which means that our sample is not significantly different from the population. So if we were to do the same exact test again, but use a different value for the population mean, say everybody who took the class before got a 75, if we run that again, we'll see the same output, and not much has changed in this analysis except for our test value and then the corresponding values down here. So in this case, Our t-value is 4.511. Degrees of freedom is the same. And then it says that our significance is 0, 0, 0. So this is below 0.05, which means that it is significant, which means that this mean for our sample is significantly different than the population mean. So because it's significant, we then have to interpret the difference. So this is final percent grade in the course. So our sample got 80.34, which is higher than our population, which got 75. So we can conclude that this course, or the people in this course, did significantly better than everyone previously that previously took the course. When you're reporting these values, you would report T and P to 3 decimal places and everything else to 2 decimal places. You shouldn't report the p-value as 0, 0, 0. So in APA style, you would report this as p is less than 0.001.